I can solve problems by writing and solving linear inequalities in one variable. Here are the keywords that you need to remember when you are writing an inequality. When we have the less than symbol, that's showing we might have keywords like fewer than, less than, or under. The less than or equal to symbol might be indicated by no more than, at most, less than or equal to. We have greater than, more than, and over for the greater than sign. And if something is greater than or equal, we might say no less than, or at least, or simply greater than or equal to. And here are the steps that we use when we're solving a word problem. Always start by identifying the actual problem. What are you trying to find? Gather the information that you already know. Use that information to write an equation, or in this case, an inequality. Solve that inequality and check your answer. Let's take a look at example number 1. Sarah opens a small coffee shop. The startup costs are $18,000. Each day she spends $400 on operating costs, and each day she makes $600 in sales. When will Sarah begin to make a profit? Let's start by identifying the problem. What are we trying to find? We're trying to find the number of days, or how long it's going to take for Sarah to make a profit. Let's let that number of days be D. Now let's gather the information that we already know. In order to make a profit, which is what we want, we need the money that she earns to be greater than the money that she spends. So the money earned is $600 per day. The money spent is $18,000 one time, and then an additional $400 per day. Remember that when we do something per day, that means we multiply that value times the number of days. So 600 times the number of days is going to be the money that she brings in. $18,000 is her one-time cost. 400 times the number of days is her cost per day for D number of days. I know that I want the money that she earns to be greater than the money that she spent in order to start turning a profit. So now let's solve this inequality for D. I'm going to subtract 400D from both sides and then divide both sides by 200, and I get that D is greater than 90. Let's go ahead and check that answer. In order to check the answer, you need to pick a value that satisfies the inequality. I chose 91 because that's the first day that's bigger than 90. 91 is greater than 90. I plugged in 91 everywhere that I had D in my original inequality, and I just worked it through to see if I get a true statement. 54,600 is greater than 54,400. So on the 91st day, she finally starts turning a profit, and her profit's only $200, but it is a profit, and it'll continue to go from there. On day 91, she will start earning her profit. Go ahead and pause and try this one, and we'll check it when you come back. Duncan is going bowling. Shoes cost $3 to rent, and each game is $2. If Duncan only brought $15, what's the most number of games that he can bowl? Start by identifying the problem. We're trying to find the most number of games that he can bowl. We're going to let that be G, or whatever variable you picked is fine. We know that he can spend no more than $15. That means that he can spend less than 15 or exactly 15, but nothing bigger than that. So the less than or equal to symbol is appropriate for this problem. We're going to set up our inequality. The shoes are a one-time cost that does not depend on the number of games that he bowls. So the 3 for the shoes does not depend on how many games he bowls. It's not attached to our variable G. It's a constant. We also know that since $2 is our price per game, we're going to multiply that 2 times the number of games. I know that he can spend less than or equal to $15. And then you work through the steps you know to solve the inequality for G. I have a D right here, my final answer. That should be a G. And we can plug in and check. So you can pick anything that satisfies this inequality. G is less than or equal to 6. I chose to plug in exactly 6 just to see if it works. I get a true statement, so I know that Duncan can bowl up to 6 games, but nothing more than that. That's his max. If you want more on this topic, be sure to check out the Learning Target spreadsheet for additional resources, videos, and practice.